Salam sejahtera to Miss Liu. In this video, I am Nur Atira and my group member from Group A would like to present about electrical scalar potential. Firstly, introduction for this topic is an electrical potential is explained the amount labeled to transfer unit of electrical charge from point to reference to selected point in an electrical field without generating an acceleration. In another point, the situation where the difference in the potential energies is an object in two different position depends on position, not in direction. Also, in electrical terms, scalar potential given that del times 2E equal to 0. E is not an area of conservativeness. Next, for the equation del dot B equal to 0, relevant for magnetic time varying as well as non-time varying magnetic field, can be write as it as a curl of vector potential because magnetic field is a solenoid. B equal to del times A. Gradient of potential scalar can be written as in slide. Only the scalar potential describe the convective field produced by electrical charge. The electric field induced by magnetic field that vary in time is non-conservative and it described by magnetic
Salam
vector.
sejahtera to Madam Liu. My name is Nurana Abu Bakar. Today I will going to present you about review of concepts in potential scalar, electric scalar. So an electromagnetic four potential may be a relativistic vector function from which the electromagnetic field are often derived. It comprises both an electrical scalar potential and a magnetic vector potential. The four potential electromagnetic is Lorentz, since both the scalar and therefore the vector potentials depend upon the frame. So the figure shows a test charge in an electrostatic field. If a force F pushes a body over a small vector distance dl, the power work is d delta F dl cos, which is angle between vectors F and dl. So this form of two vector product often occurs in physics and engineering. It is known as the dot product or the scalar product. For any of the two x and y vectors, the dot product is defined as x dot y, which is equal to xy, cos angle between vectors x and y. So for the electric scalar potentials of a given charge distribution, at a point A, which is a distance r from a positive point charge q, let us evaluate the potentials. Assume the reference point is a distance away from the reference point charge. We know that we can go along any path from A to r. So we take the simplest route. We first go along a radius from point A to point B where it intersect with the t delta r radius circle vectors E and the L are parallel along this path segment. So for the potential difference and voltage, the potential difference or voltage between 2 points in electricity is an important principle in circuit theory. Voltage is a larger term than just a potential difference. The two subscriptions tell us which 2 points the potential difference is considered. Potential difference between point A and B is defined by this formula. VAB equal to VA, and this formula we may then write into this, and therefore we can measure this integral along any path, not necessarily through point R. So finally we have to write as VAB equal to integral E dot dl. The direction of the reference point does not affect the voltage between 2 points in the electrostatic field. So that's all from me. Thank you.
My name is Nurani Syafiqah binti Ahmad Syafiqi Fikri. My matrix number is 191291945. Next, I'm going to present about the review of concept for electrical scalar potential. As we know, it should be from Coulomb's law. We clearly describe the three coordinate axes at the point, determine the vector E projections on all three axes, and add the three components as vectors, which is E equal to negative delta V over delta X Ux plus delta V over delta Y Uy plus delta V over delta Z Uz, where Ux, Uy, and Uz are the vectors of the three coordinate axes. To evaluate the projection of E on each of the three coordinate axes, we just have to separate V, X, Y, Z with respect to the that coordinate, taking the other two as constants. Okay, this is precisely the concept of a partial derivative of the distribution of a number of variables. It is often written as grad v, but far more commonly we use the Cole-Nebula operator or del operator. In the rectangular coordinate system, the operator is defined a gradient equal to delta over delta x us plus delta over delta y uy plus delta over delta z uz. Assuming that the expression vv is a shorthand for the expression in parentheses on the right side of the equation, then we should write negative gradient v is equal to negative vv over v over m, where in the rectangular coordinate system, which is gradient v equal to delta v over delta x us plus delta v over delta y uy plus delta v over delta z uz. Note that this is a function of the x or coordinate only. Therefore, at position x on the axis of the ring is E equal to negative gradient q over 4 pi e naught square root r square plus x square equal to negative over delta x q over 4 pi e naught square root r square plus x square us equal to qx over 4 pi e naught r square plus x square 3 over 2.
Hello Miss, my name is Nur Anis binti Nasruddin from RY31. Today I want to present about background of theory for electric scalar potential. In March, Alessandro Volta wrote a letter to his friend Sir Joseph Banks of the Royal Society of London. Volta drew an illustration of his voltaic pile, within it a literal pile of 24 copper and zinc discs plus salt-soaked cardboard discs. In order to use it as an energy source, Volta then connected copper wire to both the top and bottom. In principle, the voltaic pile and wires would then charge something useful, like a light bulb or a small motor, but Volta placed both wires on the tip of his tongue because neither exists. Although scientists doesn't recommend placing live wire on your tongue now, Volta has honored for his contribution to science, and in his honor, we call the volt or electrical potential measurement unit. This figure shows illustration of a voltaic pile shows how it could be used as an electric power source. The volt equal to a joule per coulomb is the SI unit of electrical potential. Consequently, according to equation below, the electrical work performed on a particle is the product of its charge and the voltage difference between the points when taken between 2 points. So this is a equation. The idea that a particle travelling through a gravitational field possesses both potential energy and kinetic energy is common to us. The gravitational field acts on the particle whenever the particle travels from point P to a lower point Q, causing its kinetic energy to increase. So next. The increase in the particle's kinetic energy is balanced by an equivalent decrease in the potential energy of the particle. Therefore, the work performed on the particle as it travels from P to Q is minus the difference between points Q and P in its gravitational potential energy. Therefore, the work done in taking a particle between 2 points is independent of the direction and thus well defined. The difference between the beginning and end points is also well defined in the particle potential energy. We can describe the electrical potential energy of a particle moving. Work performed in taking a particle from point P to point Q is equal to less than the difference in the particle's potential energy between points Q and P. The potential energy of the particle at a general point Q relative to some reference point P where the potential energy is set to 0. Below is the equation. Thank you.
Hi, my name Nik Ahmad Iman Hafiz bin Azmi. I am from RY 31. Okay, in order to achieve a minimum potential energy state, free particles attempt to pass down gradient of potential energy. In an electric field, positive charge tend to move to region with the most negative voltage and vice versa for negative charges. Okay, the transformation is shown as the equation. Okay, leave the electric field unchanged according to this equation. Okay, the potential can be fixed definitely by specifying its value at single point. The usual convention is to mention that the potential 0 is at infinity. Okay, conclusion is the electric scalar quantity may be a scalar quantity which will be used as an alternate for vector E for the narrative of electric field, and it is well defined because the line integral of E from any point of the sector to an arbitrary reference point. Okay, besides that, being a scalar quantity, the electric scalar is far simpler than the vector E for the analysis of electrostatic field. Furthermore, if we all know the electrical scalar potential as a function of coordinate, it's easy to realize the component of E in any direction and later to get the entire vector E. Okay, the last is as a final point, potentiality surface is defined as a geometrical surface with all points at an equivalent. Okay, that's it from us. Thank you.